Okay, today we're looking at finding antiderivatives of exponential functions. So yesterday we learned that the derivative of e to the x was e to the x, which means that the integral of e to the x is e to the x. And then the next example where we have e to the g of x times d prime of x dx. This is when I have something in the exponent besides just x. And so what do we have to make sure of whenever that happens? That the derivative of it is present, so that's what it shows. And if the derivative is present, then when I integrate it, what do I get? Very good. E to the g of x plus c. So that's what we're using today. When we go through these, how many are there? 8 examples? Alright, so number 1, I have the integral of e to the 5x dx. So what do we need to do? Check the derivative. So I have u equals 5x, du equals 5 dx. So that means I need to add a 5, which means I need a 1/5 out front. And now when I integrate it, what do we end up with? 1/5 e to the 5x plus c. Next one. What do I need to take the derivative of on the next one? 1 minus x. So my derivative is negative dx. So what adjustments need to be made?
Negative.
Let's take the 4 out. I need a negative on the inside, which means I need a negative on the outside. So when we integrate, we end up with
Negative 4e to 1 minus x.
very good. Negative 4 e to the 1 minus x plus c.
So what? Why is it negative 4e? There's 2 negatives.
You don't. The derivative just say.
So the negative e, the negative on e goes away.
Remember,
Yeah.
if we go back up to the top
Right the outside.
here,
Yeah.
I took the derivative of g of x, which gives me g prime of x. G prime of x is in my problem. Once I show that it's in my problem, then this is the only thing that comes out.
Okay, so once you put the negative, you don't use it.
Correct. So, once I take the derivative and I put it in here, the only thing that's going to come out
Okay.
is that.
So it's just the original is what you use the whole time.
The original plus whatever's on the outside. That's the only thing that comes out. Alright, number 3. Integral of 2x times e to the x squared. So what do I want to take the derivative of? X squared. And this one works out nice because my derivative is already there. So what am I going to get when I integrate? E to the x squared. Let's see.
So if it's not part of the derivative, then you move it out and it stays there, or it comes down with the e.
If there was a coefficient that's not part of the derivative, you move it out to the front and it needs to be in your answer. Is that what you're asking?
Yeah. What if that 2 was like a 4?
What if it was a 4 and my derivative was still 2?
You bring down 2?
Then there would need to be a 2 on the outside. Yeah, a 2 would come out.
So you just inside the problem.
Here, we'll do the problem you're talking about. Because there's one on your homework that's similar to what you're talking about. So u is x squared, du is 2 dx. I mean 2x, yeah, thank you. So I got the x there, and there is a 2 in the 4, correct? But what's extra?
2.
There's a 2. So I can rewrite this as 2 times the integral of 2x e to the x squared dx. Would you agree that this and this are the same thing?
Yeah. And then you just bring the 2 down.
So then this, since it's outside, it's got to come down. this would come down, and I'd end up with that.
So everything you bring down is everything connected to the E and everything outside of the
The E is the only thing that comes, and anything on the outside.
It's just not gonna be that easy.
All right, number 4, e to the 1 over x divided by 2x squared. So what do I want to take the derivative of? 1 over x, which is negative 1 over x squared dx.
Oh, real quick, why is that? Negative 1 over x squared, I don't get it. How you got that?
Take the derivative of x to the negative 1.
Oh, okay.
Bring down the negative, becomes x to the negative 2.
Okay.
So that means this 2 needs to end up being outside. I need a negative, which means I need another negative. Do I agree with those adjustments?
I don't understand them.
My derivative is 1 over x squared. There is a 2 in the problem that's not my derivative. So if it's not my derivative, what do I have to do with it?
Move it out.
Yes.
Move it out to the front. So I'll move the 1/2 out front.
Okay.
I've got a negative in my derivative that's not in my problem, so I need to put a negative in there, which means I also put a negative on the outside.
Okay.
Right. Why is there negative in the derivative?
Because 1 over x is the same thing as this. If I take the derivative of this, it gives me negative 1, x to the negative 2. So now when I integrate, I know the negative 1/2 has to come down. And what else?
You.
E to the 1 over x plus c.
That's nice.
Okay, now, hope we got one more.
Change that.
All right, number 5. I have the integral of cosine times e to the sine.
Sine.
So I want to take the derivative of sine. Cosine's there, so that means I'm ready to integrate. What do I get when I integrate?
E to the sine of x plus c.
All right, number 6 is a little bit different. What's different about 6?
Two.
There's 2 e's. Whenever there are 2 e's, you always want u to be what is inside of something else. So which one is inside of something else? X.
4 minus e.
The 4 minus e to the x. Why is that inside of something else? It's in the denominator. That is correct. Okay. If you can't tell whether or not one is inside of something else, then it's always going to be the one in the denominator. So u equals 4 minus e to the x. Du equals negative e to the x dx. So the only adjustment I need to make is the negative, because the e to the x is already in there.
So it's just a 4 minus e to the x comes down.
Almost.
Awesome.
4 doesn't, it's just negative e.
1 over 4 minus e to the x.
We got the negative that comes down from the outside. But what has to be done to the 4 minus e to the x?
Derivative.
Have we moved to the side? Is that what you're saying?
Oh, you gotta take the anti.
Integrated.
Are you saying it's
Would it be over
4x
2?
minus e to the x?
What'd you say? Nope.
What's the question you asked?
Oh, does it
What do I get when I integrate?
Does it have to be
Is
minus?
it
4x
4
minus
squared
e
over
to
2?
the 2x over t.
Does it need to be negative 2 so it can't be everything?
Colleen got it.
So
What do you do?
Why does it need to be in the natural log? Because it's in the denominator.
Whatever the top e. Oh,
It's
that's-
taken care of in the derivative.
That doesn't
Okay.
come out. So the denominator is what you use. You just use the log.
Yeah, if your u is the denominator, then you're going to end up with a natural log.
So,
7. I have e to the x minus e to the negative x over e to the x plus e to the negative x.
No.
Bottom. Bottom.
There's 4 e's. Okay, so it's all taken care of.
So it's all there. So my answer is
natural log of x plus x plus c.
Is that easy?
last one.
Did you say nice one or last one?
Last one. That was a nice one too. They're all nice. Alright, thoughts on this one? E to the 4x plus 2e to the x plus 1 over e to the x.
Derivative of the inside.
What did you say, Pauline?
Like e to the 4x over ex plus 2 ex over ex.
Very good. Split it up.
Oh,
What tells me to do that, Pauline?
Because it was a polynomial over
Polynomial over monomial tells me to split it up. So I'm going to have e to the 3x plus 2 plus e to the negative x.
Oh, you just. I was so confused for a second.
Now what?
Just take antiderivative of each part.
Take the antiderivative of each one separately. So on this one, I'm going to need u equals 3x, which means du equals 3 dx. So what do I end up with?
Add 3.
So I need a 1/3 e to the 3x out of that one. What's the antiderivative of 2? 2x. And then on this one, I need u equals negative x, du equals negative dx.
So subtract it.
So I just need a minus. There it is.
Don't I have like 2 other quizzes I have to take?
Yep.
Can I take one more?
Sure.
Can I take the first one?
Okay.
You know?
Alright, so if I'm integrating and there's only one e in the problem, what do we do?
Oh, so you can-
U is the
X.
Use the exponents, and when I integrate, the only thing that comes down is the e and whatever the outside is. If there are multiple e's, then what do we do?
derivative is U, the denominator is U.
The denominator is u, but sometimes it's not going to be the denominator.
It's the one that has something.
It's going to be the one that's inside. Okay? And like on this last one, if I have a polynomial on top of a monomial, split it up and do each one of them separately.